So for question 5, we have a person who deposits $100 at time 0, x dollars at time 3. So let's try to visualize what's going on. So you have a timeline, and so you deposit $100 at time 0, so you inject $100, and then this continues to earn interest. And then at time 3 you inject x dollars. And then we're told that it's growing under an interest environment of where the force of interest is equal to t squared divided by 100. And we know that the interest earned from time 3 to time 6 is also equal to x. So you have a certain amount at time 3, and then this amount keeps growing all the way to time 6. And then the growth is equal to x as well. So now we need to find x. So in order to find x, we need to find, so x is the amount of interest earned from time 3 to time 6, right? Well, the amount of interest earned is actually equal to the amount you have at time 6 minus the amount of time 3. So that's why we need to know the amount of time 3 and the amount of time 6. So let's try to find the amount of time 3 first. So the amount of time 3, we have 100, and it keeps growing all the way to time 3, so you have 83. And then you inject x dollars, so you get x. So this is straightforward enough. So the amount at time 6. So of course at time 6, the 100 is equal to 186. But how about x? So some people might say, because the x dollars has been deposited for 3 years, that's why it should be xa3. So is this correct or not? So it's actually wrong. So the correct answer should actually be a6 divided by a3. And the reason why this is true is that you can actually consider a case like this. So 1, 2. So if I deposit $1 at time 0, you have a $1 at time 1, and then if you have a $1 at time 1, it's going to grow to a2. So that is equal to applying a ratio of a2 divided by a1. So if I have a1 is going to grow to a2, that's equal to multiplying a1 by a2 divided by a1. And then, so if I have $1 at time 1 instead of a$1, so instead of a$1, I have $1 at time 1. I can just apply the same argument. So $1, I'm going to apply this ratio, and then I'm going to get a2 divided by a$1. So by this reasoning, if I have x dollars at time 3, by the time it's time 6, I'm going to have a6 divided by a$3 times x. So by that argument, we can arrive at this result. So now we know that the amount we have at time 6 and time 3, we can subtract these two expressions. So this is the amount you have at time 3 minus the amount you have at time 6, the amount of time 3. So this is the amount at time 6 minus the amount at time 3, so plus x. So this difference is going to be the amount of interest, which we're told is equal to x. So now we have our equation. So let's move everything that's related to x to the right hand side. So we have 2 of these x's, and then you minus a6 divided by a3. And then for this side we have 100 a6 minus a3. So you see that x is equal to 100 times a6 minus a3 divided by 2 minus a6 divided by a3. And then for the next step, we need to find at. So we need to figure out what at is. So we're told that at is equal to t squared over 100, right? So that's why we can apply a similar formula that we've used before. So this integral is simple enough. So you get t3 divided by 300. So all you have to do now is just to apply it to this expression. So we have 100 a6 minus a3. So 6 to the power of 3, that's 216. And then minus a3, that's 27 divided by 300. And then you have 2 minus a6 over a3, so it's just e to the power of 216 divided by 300. So if you substitute all these numbers into your calculator, you're going to get an answer like this, 784.5930809. So this is question 5.